Go.
Hey, our project is a priority task manager. Basically, what we're doing is we're taking a max heap and a pairing heap, and we're using the insertion function and the extract function, and looking at how fast it is to do both of those. So we're generating a task, we're putting them in, we're inserting them, and we're extracting them, and we're using a stopwatch to see how long it takes for looking at the time efficiency. And this is important in the real world where data structures and are used for on a much larger scale to the point where a small difference in efficiency will really add up over time to be much larger than it is.
So we're using a pairing heap data structure for this project. A pairing heap is a type of heap that offers fast operations like insertions, merge, and extract max. So when you insert, it uses the merge operation. A pairing heap is implemented as a general tree, a binary tree. Each node has a pointer to its left child and a sibling. This allows each node to have multiple children with just two pointers. New nodes gets inserted into the tree, and then the merge function gets called based on the priority. What the merge function does is that the larger node becomes the root and the smaller node becomes the left child. Okay, now we're going to go into our program. So running our program, as you can see, there's three options. We're going to go with the first option, simulate. So as you can see, there's about 10 different options. We're going to click the first one, quick simulation. Quick simulation generates 100,000 data points, randomized completely, and puts them into the heaps and checks their insertion times and extract max times. So as you can see, it gives you the time for each max heap and the pairing heap. And as you can see, overall, the max heap is doing better than the pairing heap in this specific instance.
And we also have the option to change specific aspects about the data. So in the real world, of course, there's going to be a lot of different types of data. So there's going to be smaller data sets versus larger data sets. There's going to be ascending versus descending. So basically, if they're ordered or not. And there's also verbosity, which is basically if it prints something to the screen. And if it prints something, it's going to be slower, right? And we also have the ability to adjust the priority range. So these basically all make it so that we can simulate a more realistic data set based on your specific needs.
All right. So with those options in mind, then there's more functions we can do here. So this is a very flexible sort of shell for the program. So as I'm going here, we can say add more tasks as we want individually to our program. So let's say here, I'll add just 990 tasks randomly, and we'll have these generated automatically. And you'll see that the tasks are added, and as such, they're generated. So now we can also try this again, but like add tasks manually. So let's say we'll add one manual task like so, and we'll add a name. Let's say just task one, and let's give it a priority of, let's say, one. So now that we've done that, we can also remove tasks as we wish. So we can go here to extract tasks from the heaps. And as we do so, let's extract like 600, and you'll see these, and again, we see the stats, we see which perform better, and as such. And so now that we've done this, we can save our data that we've generated here to a CSV file. So we'll go ahead and do that. And now that we've done so, you'll see that it writes to a log file, and then we'll return to our menu and we'll exit the program. So now that we've done so, we can feel free to open our log file. And here you'll see that essentially we have a CSV file here of all of the different parameters and whatnot based off of the operations that we performed. So for example, we see here our first add and remove. These were from the quick simulate. And you'll see the quantity here, the timer, the status of the timer, whether it's on or off. And then you'll see the time taken for the max heap for this operation, the time taken for the pairing heap, and the sum of each heap's timers at the end of each operation as well. And based off of these, you can do model these, do whatever analyses you wish to see how the different data structures compare to one another. And so that about wraps it up for our CSV implementation and for our implementation of this comparison of the heaps for our project.
Thank you.